All right, let's take the data off of our apparatus. What you're looking at is point B. So this is point AB. A is directly underneath the launch apparatus, and I used a plumb line to figure that one out. And our line AB, that you can see there's 5 dashes, and this is where the average is. But let's actually just read off all the averages just to be scientific about it. So point number 1, 1 meter 50, so let's see, 40, 1.4, 1, 2, 3, 4, 5, 6, 7, 8. This is 1.48, this is 1.49, and this is 1.50. So this is 1.48 what? Let's see, 1.481. So this is 1.481 meters. And this is number 2. That's exactly 1.484. So 1.484 is number 2. Number 3, that's this guy right here. It's right in between these. So it's like 2, 4, 6, 7. 1.487. 4 is 1. It's almost 1. It's 1.49. I'd say 1.492. And 5 is 1.493. Oops, sorry, I got those on top. All right, so our 5 values for AB, average them out, and you get a value for AB. Now, the line AB, what I'm going to do is put this right over these. So this tape will be what I'm going to measure C and D from. So here's D. You can see it's a lot more scatter. Once we collide, the collision produces a lot more scatter in the data. So you see all of our 5 points? What I want to do is measure the distance from line AB. So I'm going to put the meter stick right in the middle. And you can see, I'm sorry, this is D over here, D. C is over here. So C to the midpoint, I can call that like AD, or, I'm sorry, I keep saying C. I'm doing D first. I don't have to, but I just happen to be over here. So let's actually just measure each one of these from the midpoint of the stick here. So the first one is 50, and that's number 1 here. Let's just label it 1, 2, 3, 4, and 5. So now what we're going to do is measure the cross components, the Y components. So this looks like it's 57.5, right? Or 0.575 meters. Point number 2. Point, oh wait a minute, you can't see that. 0.555. 0.555 meters. 55.5 centimeters. Here's number 3. That's a little more than 54.5. 57? 0.547. 0.547 meters. Number 4. Oops. Looks like it's right at 54.540. And the last one, up at the very top. There we go. Number 5. 0.505. 0.505 meters. All right, so we've got 0.575, 0.555, 0.547, 0.540, and 0.505. And again, you find the standard deviation is a lot higher on this one than the initial momentum. And whenever you're doing collisions, there's a lot more random error involved. So what you're seeing is the more of the random error. So this is where the other ball landed. Now it landed a little bit further down. So again, we're taking the y-axis, the cross ones, from the midpoint. We also are going to get the x components too, but let's just focus on one at a time. So again, let's do 1, 2, and there's actually 2 in here, 3, 4, and then 5. And again, it's not quite as much scattered as the other one, but you can see it's pretty scattered. All right, so now the first one is 50, 50, let's get rid of the parallax error here, 0.506, 0.506 meters. Now again, these components should be equal and opposite to the ones we just measured. You can see they're a little bit off. I had like around 0.55. Here I have 0.506. So they are a little bit off, but they're pretty close. We're going to find the percent error at the end. So the second is, let me make sure, 0.475 meters. And 3 and 4, they look very close, don't they? They look right on top of each other. 0.467 for both of them. All right, one's probably 0.468 if you really want to be picky about it, which, of course, we want to be picky. And this is 0.453, right? 0.453 meters. All right, so we've got 0.506, 0.475, 0.467, 0.468, 0.453 meters. So you average those out, and you get an average value for the y component. So now we're going to do in the next video the x components.